So according to Hooke's law, the extension of a spring is proportional, extension or compression proportional to the, but we can still like, bro, so how you will know that it's important to know the points. Like when you have a force in extension graph, first point, we have a straight line. What we call that as the last point, it's directly proportional. We call limit of proportionality. Then we are still adding the load. The extension is also increasing, but not with the same rate. So we cross the limit of proportionality, and we have elastic limit is a point. If I return the loads before elastic limit or within the elastic limit, it will return back. But if I added load and we cross the elastic limit, so it won't return back. It will have some extension. So it will have extension and it will deform plastically. So within this point, I will return back to the original length. Beyond the elastic limit, it will not return to the same original length. And energy stored in the spring is half force into extension or half kx square. Because how we got half kx square? Because we have the formula F is equals to ke, and energy stored in the spring is, for a Hooke's law region, the energy stored in the spring is half base into height. So base is into extension E, where F is equals to ke. So in place of F, if I write ke, in place of F, if I write ke, so it will become half ke multiplied by E. So this will turn out to be half ke square. So if spring constant is a constant value, so what is the relation between the energy stored and the extension of the spring? It is directly proportional to square. Means if I double the extension, the energy stored will be 4 times. If I triple the extension, the energy stored will be 9 times. If I quadruple the extension, the energy stored will be 16 times. So for a spring, the energy stored by the spring is proportional to extension square, if it is having a constant value of a spring constant. So we have the limit of the proportionality and we have elastic limit. So if I draw an unloading graph, within this point, it will return back. Unloading graph within the elastic limit, it will. But beyond the elastic limit, it will not return back to the same original length. And we have the deformations, like any deformation before this is an elastic, any deformation after this is a permanent or a plastic deformation. As you can see here, the deformation of a spring. First, we have a straight line. This is a Hooke's law region, and the limit of proportionality till this point, it obeys the Hooke's law, or force and extension are directly proportional. After this point, we have elastic limit. If I remove the load after elastic limit, it will deform permanently. And area under the graph will show how much energy remain in the spring. Now the spring systems or the network of the springs. Like if we have one spring which is loaded by mass M and the force is example F, and the extension is X here. So what is the extension here is X and the spring constant is K, because what is K here? K is F divided by X. So we call that as a K. Now, what if we have two springs which are connected side by side? So if there is a force F is there, so how much force experienced by each spring? How much force experienced by each spring? If the total force is F. So it will be half of it, that's right. So each spring will experience F by 2 and F by 2. And we know force is directly proportional to extension. You can say extension X or E, it's the same thing, no difference. So if the force is half, what will happen to extension? The extension is also halved. So when we compare the whole system, when we compare this whole system, the whole system was having a force of, we have the formula F is equals to, like K is equals to F divided by E. The whole system, and we are talking about the whole system. So what is the force on the whole system? The force on the whole system is F. So we write F. But what about the extension? The extension of the whole system is not X here, it is X by 2. Why X by 2? Because each spring, the force is divided. So extension will become X by 2. So what is K here? When I simplify, it will be, because 2 is a denominator of a denominator. So it will be multiplied with the numerator. So it will be 2F over X. And what is 2F over X? We know F over X, the value of a K is F over X. So F over X is K. So the new value of the K is twice the first value of the K. Means the spring constant will be double. So if two springs are connected side by side, then the stiffness of this system will be double as the stiffness of an individual spring. So means this spring, this system, we need more force. For this system, we need more force to stretch as compared to a single spring. And the extension of the whole system is not, the extension of the whole system is not E, because if this spring stretches by X by 2, this will also stretch by X by 2. So the whole system will stretch by, the whole system will stretch, because when we calculate the extension, we calculate the extension for the system. So when a force F was applied, this force F, each spring will experiencing a force of F by 2. So each spring has an extension X by 2 and X by 2. So what is the total extension of the system? The total extension of the system is same as extension of the individual spring, because they are connected side by side. So if I say this increases by, if I say it originally they were having a length of 10 centimeter, and now when they are loaded, they both have a length of 12 centimeter. So extension of each is 2. And what is the extension of the total? The extension of the total is also 2. So the extension of the system also become half. So when we compare the spring constant of this system, which is having a total extension of half, and the total force was F. So what is a spring constant? A spring constant is a total force divided by total extension of the system. So when I simplify this, it will be 2F over X, and F over X is K. So I can say that this system will have the twice stiffness as compared to an individual spring. So when the springs are connected side by side, when the springs are connected side by side, the system becomes stiff, and it will become hard to stretch. That is why, like for a bodybuilding or an athlete, use a chest expander. For the chest expander, it is having lot of springs inside, which are connected side by side. So what is the advantage of connecting these springs side by side? So when the force is applied, that the system becomes stiff. So we need a greater amount of force to stretch them. Is it clear? Anyone having a doubt or a question till this point? So remember, whenever springs are connected in parallel, like side by side, it means the stiffness will become twice. Like if I say this was having a stiffness of 20, this will have a stiffness of 40. Irrespective of how, and for two springs, and if we If we have 3 springs side by side, then it will become 3 times. 4 spring, it will become 4 times. So if I have like 3 springs which are connected side by side, and I add a load F, so this force F, this will be F by 3, this will be F by 3, this will be F by 3. If we add them vertically, then there's another way to do. Like if we connect end to end, then it will become less stiffer. So this force F by 3, how much extension it will cause? It will cause extension of X by 3. So if I want a spring constant of this system, the total force is F and extension of individual spring is extension of the same, all, it's same. So this will become 3F over X, and F over X is K, so I can say 3K. So means now the stiffness of this system is 3 times the stiffness of the individual. So the number of the springs I attach, the greater number I attach, the stiffer it get. But what if we connect the springs end to end? Like one is straight spring attached to another spring and they're connected end to end. Now what will happen if there's a force F is there, like say 2 springs are there. This is spring 1 and this is spring 2. So how much, if a force F is there, how much each spring will experience? This will experience a force F. This will also experience a force F. Each spring end to end mean like I have one spring here. Then after one spring, I connect another spring. And then I add a load F. So this load F, how much force is acting on the first spring F? How much force, downward force acting on the second spring also F? And we know force is directly proportional to extension. So what is the extension of the first spring? X. Extension of the second spring is also X. So what is the total extension, the total increase in the spring? That is equals to 2X. So if I need the spring constant of this system, which is force divided by extension. So force is F. And what about the extension? The extension is 2X. So the new spring constant, it will be 1 over 2 F over X, and F over X is K. So I can say the spring constant or the stiffness of the spring will be half of the spring, the stiffness of the spring will be half of individual. So it means it will become easier to spread the springs when they're connected from one end to another as compared to when they're connected in parallel. So when we add a load of like 30 Newton, how much force act on the first spring? 30 Newton. And how much force act on the second? 30 Newton. But when we talk about the force on the system, so how much force is applied on the system? The force applied on the system is F. This F is the force which we applied on the system. But individually, each spring will stretch X, so the total extension will be double. So when we simplify, the new spring constant will be half of the first one. Is it clear? Any doubt in this? So remember, whenever springs are connected in series, like one to another, it will become easy to stretch. So if the springs are connected in parallel, it will become difficult. But if springs are connected in series, I can stretch them easily. Like the system will become less stiffer. So if I attach a force of 30 Newton, this will experience 30 Newton. This will also experience 30 Newton. And this will also experience 30 Newton. If this increase 2 centimeter, this increases 2 centimeter, this also increases 2 centimeter. So what will the total extension of the system? The total extension of the system will be 6. And the total force is 30. So 30 divided by 6, the spring constant will be 5 Newton per centimeter. But if I talk about individual spring, like I was having an individual spring, which was having a force of 30 Newton, and it was stretched by 2 centimeter. So what is the spring constant for this? So it will be 30 divided by 2, which is 15 Newton per centimeter. So individually, spring was difficult to stretch, but when I connect them end to end, it becomes 5 Newton per centimeter. So I can easily stretch them. So if I want to reduce the stiffness of the system, I will connect the springs in series. But if I want to increase the stiffness of the system, I will connect the springs in parallel. Is it clear? Any question or doubt about till this point?